Terrific. Well, welcome everyone. Good evening. Welcome to the May meeting of the RASC, the Ottawa Centre. It's a pleasure to have you here tonight. New folks, people who haven't been here, could you raise your hands? Wow, excellent. Well, welcome. We've got a treat for you tonight. It's nice to see you. We'd love to chat with you at our break and talk to you more about what brings you here tonight, what your interests are. So next slide, please. Okay, by way of our program tonight, a brief introduction from me, followed by, usually we have Gary Boyle, our president, give an overview of what to expect in the skies above us in the month of May, the sort of prominent objects. I'll be presenting on his behalf. We have a special guest, Dr. Armitage from Carleton University, the physics department, will be talking about a tool that he and his project team have developed to detect and provide early warning of solar storms. Okay. Following that, we're going to have a break. We have door prizes that we give away. It's open to everyone, and we give away those door prizes at the end of the meeting. Come get your tickets for those door prizes, and we'll do a draw at the end of the meeting. We have a selection of door prizes right in front of me that we'll be raffling away. And also, Tilla just brought up a few moments ago some binoculars, which we'd like to donate, which we'd like to give away as part of the door prize. We want to give it away to, let's say, 16 and under, okay? So if you're an adult and you have somebody you brought with you that's 16 and under, okay? What do you say, Attila, 16 and under? Let's go with that. We'd like to give these away to somebody, a youth, somebody that's younger, let's say. Pierre Martin, holy smokes, Pierre is he might not want to call himself this, but I would call him an expert on meteor showers and meteor observing. He's going to tell us what to expect in May. We have something very special, potentially something very special coming up. Followed by a trip report from John Thompson. Now, John Thompson, as you know, he's our Ottawa Centre member. I saw him at the end of the last meeting, and he just came off a plane from his trip to Chile, and you could see that he was showing that he had just been on a long plane ride, and he thoroughly excited me about his trip to the Atacama Desert, and I'm hoping you'll pick up that enthusiasm that I did. I want to talk a little bit more about that because I have an idea I want to pitch to everyone after John's presentation. After that, we're going to wrap up with a variety of astronomy outreach announcements and so on. Next slide. Okay, welcome to new members. So far this year, we have 27 new members. Is Dan, Allison, Murray, Samantha, Andrea, Claude, Bob, or Eric? Are any of you in the audience that I can't see? If you are, just say yes. Oh, that's wonderful. All right. Well, welcome, and again, I'd love to chat with you at the break or after the meeting. It's nice to. I'm going to talk more about what membership brings, but it's certainly nice to have you, and I'm sure you'll contribute to the group. That's wonderful. Next slide. Okay, I'm Gary this month. I'm presenting on Gary's behalf. So let's see how I do here. So what to expect in the if you look up in the month of May, well, what's been prominent, actually not just in this coming month, but for the last couple of months, has been Jupiter. Jupiter's high in the sky, in the southwestern sky. Once the sun sets, it's still very high up. It's in the constellation Gemini, and what makes it interesting is that it's right very close to Castor and Pollux, the heads of the Gemini twins. So the three of them together all make a very interesting trio to look at. Okay, thanks. Pollux and Castor. Okay, next slide, please. Okay, off to the southeast. You'll notice this reddish, orangish object. Well, that's unmistakably Mars, and just on in the constellation Virgo. Mars and Earth a couple of weeks ago, or maybe it was just just over a month ago actually. Earth and Mars was in opposition, meaning there was a line you could draw between the Sun, Earth, and Mars. All right, so Mars was very, very prominent here. Over the last couple of weeks, Mars has been moving westward against the background stars. That's retrograde motion, as Earth in its path around its orbital path around the Sun is moving a bit faster. And then up until May 21, that it'll start becoming stationary against the background stars, and then it begins its eastward trek again. Always interesting to watch over the weeks. But certainly Mars is very visible, magnitude -1.5, I understand, and so forth. 25 months from now, it'll be back in opposition again. And you can see there off to the lower left, Saturn is, I think it's rising around 9:30 or just, or appearing around 9:30. It's in Libra, and so you can actually, I was noticing that Jupiter's setting after about around 12:30 right now. So it is possible to see all three planets. So what a treat. Now, if we can only do away with these clouds, then we can actually see them. Okay. Okay, morning skies. Venus, unmistakably visible. On May 15th, Venus is very close to Uranus, about 1.3 degrees, or about almost 3 full moon widths away from Uranus. I was reading as I was preparing collecting my thoughts for this presentation here that Uranus is naked eye visible. Now, I've never seen it with my naked eye. Has anybody in the audience seen it? So I'm a little dubious about that. Anyhow, Venus, it has been very striking in the morning sky for, oh my gosh, the last 6 to 8 weeks. Okay, what about the moon? Well, Gary likes to point out always that the various names for the moon. We had a flower moon coming up, and what else can I tell you? I think that's about it. Other than the fact that we have, as I said earlier, something really special coming up on the evening of on the May 23rd, 24th, and it may very well be the astronomical event of the year. So I'm not going to say anything more about that. I'll let Pierre Martin speak to it. He'll do a lot more. He'll give a lot better overview of what to expect. So until next month, hopefully some more clear skies. Okay, Gary also included this. This is funny. This is a snapshot from the Today program. This was, you remember the lunar eclipse we had a month or so ago, or a couple of weeks ago? So you can see there on the left the sun's rays there, of course, and the Earth, and this funny, odd-looking object, which is not the moon. So someone had copied and pasted I don't want to say a moon look-alike, but it doesn't look like the moon. It looks more like Mars. So a Martian eclipse. I don't know. Pardon me?
It's the death disco.
Okay. So interesting that it can actually make its way to a national audience. Bad astronomy, I guess. All right. It's my privilege to welcome John Armitage. He's from the physics department at Carleton University. As I mentioned earlier, he's going to talk about a tool that him and his project team have come up with to provide early warning against solar storms. Folks, please welcome John Armitage and thank him for coming to visit us tonight.
Well, thank you very much for inviting me here, and I must admit when I got the invitation I did hesitate a bit because my background is not in astronomy. My background's more in high-energy physics, particle physics, and so I was really concerned that you might be pitching me some tough astronomy questions. And however, the project is sort of half and half astronomy and particle physics, as you'll see, but we do need to talk a little bit about astronomy. So what I'm going to talk about tonight is space weather, really. And I'm going to start by talking about the effects of space weather. That's obviously satellites and objects like that are very vulnerable to space weather. But also there are atmospheric effects, so the space weather affects the Van Allen belts, and those affect then radio communications around the world. And in extreme storms then, when these space storms get down to the surface of the Earth, the magnetic fields there can induce large currents in conductors. So there's 3 or 4 different ways there in which the storms can affect us. And I'll go back and talk about a couple of the larger storms that have occurred, and also talk then about where these storms are coming from, So on a normal, peaceful day, we have the solar wind, which is bathing the Earth. But it can blow up, and there can be these massive coronal mass ejections that blast plasma at the Earth. So that's the one that we're really concerned about. And we would also like to have some warning of one of these coronal mass ejections are taking place and when they're going to hit the Earth. So the early warning comes about from primarily satellite information, and I'll talk a bit about some of the satellites which can be used to give us some warning of these storms, and also talk about the use of another modality, using cosmic rays to anticipate the arrival of these storms using a cosmic ray detector. And that's the detector which I'm working on. Okay, so let's talk about the effects of space weather. So obviously satellites are very, very vulnerable to these plasmas which are emitted from the sun. And weather forecasting satellites are certainly vulnerable. Of course, the extreme weather that they have down in the States with the tornadoes and so on, it's very, very important to have a continuous update then of where these storms are going. And if one of these satellites then is taken offline for 6 hours, 12 hours or a day, then you lose track of where the storm is going, and you lose the capability of giving some early warning to people in the path of the regular storm. Also, there's the International Space Station. So the ISS astronauts there are alerted if there's a storm coming. They're told to get back into the space station. So they have to go out and do regular maintenance on the exterior of the station. But if there is a storm coming, then they need to get back inside the space station. Also GPS, we're increasingly reliant upon GPS. So boats and aircraft all use GPS, and without GPS, then suddenly the pilot is thrown to their own devices to steer the plane or the boat. Coming down into the atmosphere, as I say, many of the atmospheric problems are due to radio communications, and commercial flights that fly over the pole rely a lot on radio communications for direction finding and so on. So there's not a regular sort of radar contact with the flight once it goes over the pole. And it's really down to radio communication to keep the pilot updated with where other planes are as they go over the pole. And then once you get down to the ground, on the ground it's usually the magnetic fields which cause the problem, and these can induce currents in the power lines and the pipelines. Okay, so one of the first times that these events were correlated with sunspots. So sunspots do seem to be where all these major storms originate. And one of the first times that this correlation was recognized was back in 1859. So in 1859, there was this astronomer, Robert Carrington, who was recording the sizes and the shapes of sunspots. So what he had done then was to take a regular telescope, and he had projected an image of the sun onto a piece of paper, and had expanded the image so that the sun sort of occupied about a 12-inch square of paper. And then onto that square of paper was projected not only the sun, but also obviously the sunspots. So then he would take his pencil and would then mark out the position of the sunspots on that piece of paper. And then he could calculate the area of those sunspots. And indeed, the monitor that we use is the area of the sunspots divided by the area of the sun. That gives us a measure of the sunspot activity. So he was so engaged in drawing this sunspot when all of a sudden he saw a bright flash of light which appeared at these points A and B, these 2 points here, A and B. right in the middle of the sunspot. And at first he thought that there was something wrong with his apparatus, so he went to check the filters and make sure that there was nothing wrong with the filters. He came back, it was still there. And then he went off to call a friend to witness this. But unfortunately, before the friend could get there, the lights, the big bright flashes, had disappeared by about 11:23. So 5 minutes later, the flash had disappeared. And then 17 hours later, there was an intense aurora observed on Earth. So both the North Pole and the South Pole exhibited this very, very intense aurora, and it was observed at latitudes much further south than normal. So it was down to places like New Orleans in North America. And the fact that this occurred 17 hours after the time that he witnessed the flashes indicates that the ejector must have been travelling at velocities of about 3,000 kilometres a second, which is pretty fast. Now, in fact, this Carrington event was actually the second of two events that took place in 2 or 3 days. So this was the one on September the 1st, but there was also one on August the 28th. And indeed, it affected, as I say, both the North Pole and the South Pole, and we got the Aurora Borealis and also the Aurora Australis. Yeah, well, the other one anyway. So in those days, of course, we didn't have any satellites, and there weren't any radio communications. So communications around the world were made with telegraph cables. And in 1859, there was something like 100,000 to 125,000 miles of telegraph cables in the US, Australia, India, and Europe. And it was those telegraph wires then which, again, told the story of the arrival of that solar storm. So the Sydney Morning Herald reported that yesterday morning at about 10 o'clock, the wires of the electric telegraph were seized with an unaccountable fit of restiveness. They did not altogether refuse to work, but they acted irregularly. And indeed, over in the US, a similar situation was experienced for the storm following the Carrington event. And the Washington Daily National Intelligencer reported that these two US telegraph operators said the wire was then worked for about 2 hours without the usual batteries, working on the auroral current. In fact, working better than the batteries were connected. This is the first instance on record of more than a word or two having been transmitted with the auroral current. So they were able to operate the telegraph system then without having it plugged into the batteries. And another poor operator over in New York said that during the display, I was calling Richmond and had one hand on the iron plate. Happening to lean towards the sounder, which is on the wall, my forehead grazed against a ground wire, which runs down the wall near the sounder. Immediately, I received a very severe electric shock. So these storms then can induce very high voltages, very large currents in ground wires. So this is the only equation that I've got in the talk. And this equation is explaining the generation of currents on the ground. And really this equation is actually Ohm's law. The variable on the left-hand side is GIC, which is not investment certificates. It's a geomagnetic induced current. So this equation is connecting current with voltage. Although instead of the voltage, I've used electric field, which is measured in volts per meter. And so then you have to multiply by the length of the conductor. And the A and the B in this equation are the lengths of the conductor in the north-south direction and in the east-west direction, respectively. And then to complete Ohm's law, you need resistance. And the variable C is actually 1 over the resistance. It's the conductivity of the ground. So this is connecting then the induced electric field with the current. And that induced electric field is caused by fluctuations in the magnetic field. So the time rate of change of the magnetic field in the east-west direction generates an electric field in the north-south direction, and a time rate of change of the magnetic field in the north-south direction generates electric field in the east-west. And this comes from a paper which was written by a Finnish group, and they were working with power lines that were 1,000 kilometers long, and they found that 60 amps of current was induced by a fluctuating magnetic field of 8 nanoteslas per second, which is a very, very small field, compared with the Earth's magnetic field, which is about 30 microteslas. But the reason that the current induced is so large is because of the long length of the conductor. So although it's a smaller magnetic field, with a long conductor, then you can get these large currents induced. And these effects are also felt on power lines, telegraph lines, and pipelines. In 1989, there was a power outage in Quebec. In Quebec, they have about 11,000 kilometers of lines, which are carrying power from, oops, sorry, I always do that, press the wrong button, there we go. Carrying power from James Bay, from the reservoirs up there, down to Montreal and Quebec City, and then also carrying power from Churchill Falls across and then down the St. Lawrence, again down to Quebec City and Montreal. So it's about 11,000 kilometers of power lines. And in 1989, a magnetic storm then induced ground currents which tripped the whole system. So this caused about $10 million of damage and blacked out the whole system for about 9 hours. So these storms can have large effects on ground-based installations. Another installation that was hit was the Anik-1 satellite. So this was a Canadian communications satellite, which was in geostationary orbit. And in 1994, one of these solar storms wiped out Anik-1. Its cost then was about $250 million. But that was 20 years ago. Okay, so the origin of the space weather is the sun. So the sun then, keep doing that, has this core where all of the fusion reactions take place, and then a radiation zone which transports the heat, and then finally a convection zone where the heat then is transported by material, and this material is bubbling around, moving up to the surface and back down again in convection currents. And what's being boiled off is really electrons, protons, alphas. So these are all the byproducts of the fusion reactions that are taking place down in the core. And they're regularly streaming away from the sun at velocities of about 400 kilometers per second, or at least that's the velocity by the time it gets to the vicinity of Earth. So what's coming towards us then regularly is an ionized gas, a plasma, which can generate magnetic fields as well as electric fields. So this plasma, as it interacts with the magnetic field of the Earth, what it tends to do then is to compress the magnetic field of the Earth on the solar side. And in fact, the magnetic field here saves us from a lot of the radiation. The magnetic field bends the particles, moves them away from the Earth, and these particles are then deflected around the Earth. But some of them are able to leak in through this, what's called the polar cusp area. And these are the particles then that create the aurora borealis or the aurora australasis. So this channel here is a fairly low impedance channel for these particles to get in. But the rest of them are deflected away. So the magnetic field here really is saving us from a large amount of radiation which we would otherwise receive.
Can you go a bit closer to the mic, John?
Yeah.
Thanks.
So the origin of this is supposed to be sunspots. And sunspots then are these dark areas which appear on the sun. They appear dark because they're comparatively cooler than the surroundings. So what is thought to happen is that the outside area of the sun, the chromosphere, is disrupted by strong magnetic fields. And these strong magnetic fields then produce these spots, because here we're looking through the chromosphere into the region just below the chromosphere, which is cooler. Now, this heating of the outside of the sun is not well understood, but it's thought that this is due to the reconnection of magnetic flux lines in the chromosphere. So the chromosphere is hotter than the part below it, and you're able then to see sort of below, through the surface, down to the cooler bits just below it. But occasionally, these sunspots then can produce a large eruption of plasma, like the one that Carrington saw. But these plasma eruptions can be massive. This is the size of the sun itself, and you can see that the size of the CME, the coronal mass ejection, is at least the same size of the sun, if not larger. So these are massive, massive things, and they blast off into space. When the plasma then arrives at the Earth, what is crucial is whether the magnetic field of the plasma is in the same direction as the Earth's magnetic field or opposite. If the plasma magnetic fields are opposite to the Earth magnetic field, then it will collapse the Earth's magnetic field, and then all of this plasma can then penetrate through and hit the surface of the Earth. And that's what happens during one of these major solar storms, and that's what produces the aurora at the very low latitudes, and what produces these ground currents induced by the magnetic fields, because the plasma is allowed to get right into the surface of the Earth. So it removes the shielding effects of the Earth's magnetic field. So what advance warning do we have of this? The advance warning is provided by 5 satellites. There are 2 satellites which are moored at the Lagrange point. So this is a point where the gravitational attraction of the Earth is equal to the gravitational attraction of the Sun, and it's about 1/100th of the way between the Earth and the Sun. And at that Lagrange point, there is a satellite called ACE, the Advanced Composition Explorer. That's this thing here. And ACE then is the one which measures the particle velocities. So that wind speed that I was quoting of 400 kilometers per second, that was measured by this satellite ACE. So ACE also measures the composition, whether they're electrons, protons, alphas, etc. And then, in addition, there's another satellite at the Lagrange point, SOHO, the Solar Observatory and Heliospheric Observatory, which has 2 instruments, a large angle observatory and also an extreme ultraviolet telescope. And this large angle device studies the corona by blocking the sun itself with a disk. And by blocking that, it's able to then study the corona around the outside of the sun. But these 2 don't really give us good information about what direction the solar storm is going in. So this one, because it's parked only 1/100th of the way to the sun, by the time the solar storm reaches this one, it's almost at the Earth, and we don't have much warning. And with this one, although it can view the sun, it's very difficult to tell if the storm is coming towards us, because the sun here is blocked out by this disk. So in order to get around that problem, there were 2 other satellites launched, Stereo A and B. A was launched in advance of the Earth's orbit, and B was launched behind the Earth's orbit. So the idea was that as this one moves ahead, then this was its position in February 2011, and it could view then the space between the sun and the Earth, as could the one that was launched in the other direction. So they could both view the space then between the Earth and the sun and get a stereo view of any storms. However, we're now in 2014, So in 2014, the satellites are here and here. And indeed, by 2015, they'll be sort of directly behind the sun. So they're not going to tell us about storms coming towards the Earth. There was another satellite launched in 2010 called the Solar Dynamics Observatory. And this one was placed even closer to the Earth. This was placed in a geosynchronous orbit. So the advantage is that this enables real-time communications. So the previous satellites, the transmission of the images takes a very long time, and it's definitely not real-time observatory. But this one, because it's in geosynchronous orbit, you can have real-time communications then between the satellite and Earth. However, again, you have to sort of guess in which direction the solar storm is moving. So we've been looking at another way of measuring these solar storms using cosmic rays. So these cosmic rays then are the particles which the whole of the universe is bathed in. Their origin is supernovae and galaxies many thousands of miles away. And the whole of the universe is bathed in this particle flux. 80% of them are protons, about another 15% are alphas, and then the rest are higher nuclei. So when they interact with the Earth's atmosphere, which they do around about 15 kilometers up, they produce a shower of particles, which includes pions, neutrons, protons, etc. And then these pions decay, producing muons. And the mu particles are very long-lived, or comparatively long-lived. And it's the muons which we detect here on Earth. They're long enough lived that they will penetrate right down to the surface of the Earth. So by detecting the muons, then you can get an idea of the number and the rate of the primary particles. So the rates have been monitored for many, many years. And there was a physicist called Furbush who was monitoring these rates back in 1937. So he noticed that the rates, and they're indicated on this graph with these dots. These dots are the rates that he was recording. And he noted that they correlated with the changes in the magnetic field due to these solar storms. So the continuous line here is the magnetic field measured by magnetometers on the Earth's surface. So there seemed to be a correlation then between the magnetic field and this decrease that he observed in the rate of the cosmic rays. Now, unfortunately, of course, he was doing his work at a time just before the world was thrown into chaos by the Second World War. And it wasn't really until 1954 that this work was taken up again. And then the origin of these storms, or the origin of this Furbush decrease, was then interpreted as being connected with solar storms. So the idea is that the primary galactic cosmic rays coming from outside the galaxy are disturbed by the strong magnetic fields which are inside this plasma coming from the sun. And it deflects the rays around and reduces the rate that we observe on Earth. Now, there is a global muon detector network existing in these 4 stations of Japan, Kuwait, Australia, and South America, Sao Martino. And these observatories look at cosmic rays which are originating in the positions shown by these coloured squares. So these particular observatories then have pairs of detectors, and they're able then to sort of point these pairs of detectors in different directions, and that's where they are able to detect these different positions, or be sensitive to cosmic rays from these different positions. So what they do is they look for correlations then between the intensity and also the magnetic field, and they look for correlations between intensity and the angular distributions of the cosmic rays. because it may be that in addition to intensity, the angular distribution gets changed. And indeed, at this point here, where you see the intensity of the cosmic rays reaches a maximum, at that point, if you look down here, this is a graph showing the angle of the cosmic rays from one horizon to the other horizon. And the red dots indicate a 5% increase. And you can see that at this particular time, correlated with the increase in the cosmic ray rate here, the angular distribution was very isometric in that there was a big increase on this side and very small increase on this side. So asymmetries in the angular distributions are another way of looking at the arrival of these storms. So we tried to do something similar using a detector which was built up at Carleton. We had some drift chambers left over from another experiment, and we used those drift chambers then to set up the experiment. Unfortunately, although it was able to monitor the angular distributions, it had limited statistical significance because of the size of the detector. So the actual rate that we were getting was fairly small, and we were looking for 5% differences. And in order to look at 5% differences, you have to have quite a large accumulation of events. So the work is being continued with the CRIPT detector. So CRIPT is the cosmic ray and cosmic ray inspection and passive tomography detector. It is set up to monitor cargo which may be crossing the border or coming in through the ports. And the CRIPT detector then allows you to see inside the cargo containers and is particularly sensitive to the presence of high Z materials like uranium or plutonium. So it can detect and discriminate plutonium and uranium from other materials like lead or iron or whatever. And it's using cosmic rays. There's a detector here on top which tracks the incoming muon. The muon is then allowed to go through the cargo, where it scatters on the contents of the cargo container. And if the contents contain uranium, uranium's a very high Z nucleus, and it scatters the cosmic rays much larger than does, say, an atom of carbon, which has a very small number of protons. So you look for these large angle scatters, and they indicate the presence of uranium. And you do that by measuring the outgoing muon, and then you take the outgoing muon track, connect it to the incoming muon track, and look at the angular scatter. So this can also be used to measure the cosmic ray rate and the cosmic ray angular distribution. So the top part of the detector acts like a very good cosmic ray detector, and it's also a very large area, so the statistics are pretty good. And these are angular distributions which have been recorded on CRIPT for one particular time interval. And you see the angle here goes from 0. In this case, 0 means vertical. And then this is 20 degrees, 40 degrees, etc. So most of the events are between 0 and about 27 degrees. This is time interval 1, time interval 2, 3, 4. So we look at these 4 different time intervals, and then we make a plot like this, which shows how the angular distribution is changing. Remember that all of the significant data is between, say, 0 and 27, and this stuff up here is really just the errors. So this is the main part, and this is showing a fairly even distribution. The magnitude is increasing, but it's increasing uniformly across the whole angular distribution. But that's the way that we can look at cosmic rays or look at the presence of storms. So in future then we're going to be using this CRIPT detector, which has a very large area detection system, try to measure the angular distribution and correlate that with magnetic disturbances. And if we can get funding, that would be great. But the problem is that extreme space weather events are low frequency, high consequence events, similar to earthquakes and tsunamis. And it's difficult to get funding then for these types of events. So thank you, and I'd just like to thank these people who funded the research in part. Thank you.
Okay, we have time for a few minutes of questions here. Tim and myself are going to be running the microphones to the audience, but I want to start off with a real quick question. And thanks again for coming. I really appreciate you sharing your time on this Friday evening. It's kind of you. Has a crypt detect be deployed in space?
It certainly could be. I mean, not in the implementation that we've got here, because that crypt detector that we've got here weighs 20 tons. And but yes, it could be deployed in space. And indeed, there is already a particle physics experiment on the International Space Station.
Okay.
And that is also measuring the solar wind and things like that.
And there is advantages in deploying it in space, I take it?
Well, the advantage of a ground-based system is that it's accessible. You can get to it, you can maintain it, you can get real-time data from it. There's no delay involved. With the space-based systems, one of the ways that you know that a solar storm is coming or a solar storm is present is that your satellite system will suddenly go dead. And then when your satellite goes dead, you know you've got a solar storm. With the ground-based systems, they remain active and tracking. So,
Thanks.
Two questions actually. The one, I saw Crypt in the basement there. It's quite imposing. But I heard that you're selling it, yes?
not selling it, but part of the funding, as you'll see, came from Atomic Energy Canada.
Yeah.
And Atomic Energy Canada funded a large part of that detector. And as part of that funding agreement, the detector has now gone up to Chalk River.
So will it be used for this work? I was designing a satellite, I think last summer, for the CSDC, and our payload was a scintillator to sense cosmic rays. I was on the engineering team, not the science team, but is that at all related to this work?
Yeah, so was your scintillator a cesium iodide detector?
Oh, I'm not sure actually, but I know it was a particle sensor of some type.
Yeah. Yes, it certainly could be part of this work, but I guess the only problem with that is the size of the satellite. So from what I understood, if I've got the right satellite, I think your detector is about sort of yay size.
Yes.
And these solar storms are enormous.
Okay, thank you.
Other questions? I'll give you the microphone.
I've just recently read an interesting couple of science reports that if we have another Carrington event in our electronically electrified world, that it has the possibility of shutting down the entire world, killing most computers, shutting down cars and trucks, and causing a monster of a disaster. What are the odds of that happening again? Have you got any figures on that?
Well, the odds are quite low because obviously that Carrington event occurred in 1859. We haven't had one of the same magnitude since then. So that's 160 years or so. But it could certainly happen again. There's no reason why it wouldn't. And indeed, one of the main vulnerabilities these days turns out to be power transformers. So the magnetic fields generate currents in the power lines, and these power lines then are usually connected to transformers. And in the storm of 1989, there was a power transformer that blew up at one of the nuclear power plants because of the storm. And these transformers now are no longer built in North America. So the whole manufacturing of these big power transformers has gone right off to China. And you can't sort of order these transformers off the shelf. So you have to sort of put an order in several months ahead of the time. And if one of them did go off, then it would take several months to get another transformer back. So you could be looking at shutdowns of many, many months. So that's the problem with the infrastructure. Yeah.
Yeah, I have a question about the cosmic rays themselves. I saw that the crypt was looking at aircraft cans. Are they constantly streaming down, or are they sort of like once every minute? Or?
Well, the aircraft cans is only one example. So the other example that what we're going to use is containers, shipping containers.
But are the cosmic rays frequent enough to be useful in a like a port setting, or are cosmic rays more like a once in a while type of thing?
Oh yeah. The cosmic rays are coming down as we sit here. The cosmic rays are coming down and impinging upon us at 1 per square centimetre per minute.
Okay.
So if a square centimetre is about the size of your fingertip, every minute there's a cosmic ray going through there. Oh, there's another one.
What would the picture look like during the sun's later phases, like 4.5 billion years from now?
That's an astronomy question, isn't it? Don't know. Don't know.
A question over there?
Yeah. Hello. What are the odds of a CME being aimed at the Earth? Is there any preferred direction? Is the Earth in a particularly vulnerable part of the sky?
No, so so far as I know, there isn't any correlation with angle or orientation of these CMEs. They're fairly random. They are associated with the sunspots. And as you know, the sun is rotating, and I believe the period is about 28, 29 days. So as those sunspots go across the face of the sun, then the CME could be pointing in several different directions as the sun rotates around.
But invariably, they will be emitted or ejected in the plane, the solar equatorial plane.
I don't think we can even say that. I think the sunspots are pretty ubiquitous over the face of the sun. Some of those photos that we were looking at showed CMEs and flares going up out of the polar regions of the sun.
Thank you.
Okay, I think we can take one more question. Is there anyone in the back that we've been overlooking, or anyway?
I have a question.
Okay, let me bring the microphone to you there. Take one more. Thank you. Okay, I'd like to know how many CMEs have there been that we've witnessed in the past 20 years that, had they been directed towards the Earth, would have been killers? Are you aware of how many there are, or?
No, afraid not, because it's difficult to monitor the strength, the intensity of those storms if they're not coming towards us. So, as I say, the main instruments that we have for recording those storms are the satellites moored out at the Lagrange points. And if the storm's not going to pass by those particular satellites, then it's difficult to know what the intensity or what the scale of those storms are. So.
Okay, one more. Last question here.
Thank you. Very interesting presentation. Say that we can predict this or determine that something, a CME, is on its way, a large-scale one. What can we do other than telling the astronauts to get back in the space station and maybe ground the aircraft? Or?
So yeah, in the case of the astronauts, yes, you can get back into the spacecraft. In the case of the power lines, the power companies say that if they have 24 hours notice, then what they can do is they can switch off the main power lines and break them up into smaller sections. So in that equation, the length of the line was critical. if you cut the line up into small pieces, then the voltages which are generated are much lower. So they can do that, but then you're relying on local generators. So the 24-hour notice is really the time it takes to get the local coal-fired stations up and running to generate electricity and take over from the electricity from the dams.
Okay, thank you. And what's the effect on pipelines? Does it cause explosions? Or?
No, but it advances the corrosion. So there's voltaic corrosion that takes place at the joints and the wells in pipelines. And these large currents, 60 amps or so, accelerate the aging of the pipelines. But again, with the pipelines, what you can do is to split the pipelines up into electrically isolated sections, put some insulator, plastic or something in between sections, so that it's not one long conductor. And in that way, you can mitigate the effects of these storms.
Are we doing that with modern pipeline installation?
I am not a pipeline expert.
Right.
All right, well, thank you very much. Thanks for the questions, everyone. Thank you very much. Okay, observation reports. We have several members that are sharing their observations. Mike Wirfs, you may know, is, and folks, Tony, Julian Gordon, and Paul, if you could come up to the front here and to the side, and just so we can get ready and do this quickly. Mike Wirfs, as you know, he's a member of ours that's in Baja California. You've seen a number of his images in previous presentations. He's become very active sharing images, and that's to our advantage because he's very impressive. He recently, a couple of months ago, purchased a 152 millimeter Lunt solar scope, and he's been playing around with it. I think he had the shortest learning curve I've ever seen. Okay, it seems like in a matter of a week, he managed to do things that, I don't know, I'd have much longer learning curve, let's just say that.
Slowing down, is he?
Yeah. So now, Mike, you've seen his, if you actually Google Mike Wirfs, you'll see a lot of his lunar images themselves. Those pretty amazing here. A prominence here, a pretty spectacular prominence here. What strikes me about this one here, other than the fact that I feel like I'm just about ready to go into orbit around the sun here, is when I first looked at this here, and maybe I'll let other people comment about it. You can see the well, of course, you can see some of the prominences on the edge there. But look at that three-dimensional filament there. Just I've never seen it's almost worm-like. I've never seen anything quite like this. It truly is amazing. You can almost see some granules there, which are convective cells and the tops of convective cells. And this is something for an amateur. Anyone else want to make a comment about this? I'm glad I'm going to put you on the spot. What strikes you about this? Anybody?
What's the white in the middle there almost? What's that?
The white area?
Yeah.
Oh, okay, this is where I'm going to have to draw on some members here to help me out.
It's an active region, and that's actually the name of it.
Okay, now let's vacula. Okay, facula. Okay.
Yeah.
Well, let's go beyond that. Let's explain what a facula is.
It's the white thing.
All right, so can you see that again, please, Rob? A little bit louder.
Magnetic field around the sunspot is being, the vertical flow of gases up from below are inhibited around the sunspot, so the gases divert to the side, heating up the area around the sunspot.
Is that a sunspot?
Yep. It's like a little harder to see them under an inch up.
Yeah, it is, isn't it?
All right.
What's the cause of those formations, the filaments or whatever you call them? No. What you said is worm-like.
So filaments, like prominences, are emissions. They're gaseous emissions, charged emissions. Everything about the sun is I view the sun, the more I learn about it, it's a giant magnet. Okay, and it influences so many things, so many effects. The prominences, and the filaments, by the way, I should have mentioned here, are the same as the prominences. You're looking at the filaments straight on here.
are on the face versus if you're looking at them on the side here. But they follow, I understand, the magnetic field lines. And again, many of the shapes that you see in prominences and granules and so forth are as the warm gases and convective currents flow up. Because there's so many charged particles as it impacted, it's very much influenced by the the local magnetic fields and so forth. I hope I got that right. And by the way, I mean, a lot of this is that's the current view. I think there's it is well known that sunspots are intense magnetic regions. There's something called the Zeeman effect, which shows that if you look at spectral lines coming from from those sunspots, it's we know that the spectral lines are split into pairs, kind of like what I read recently, as if a drunk was looking at the lines. You see two of them. But when you see that kind of splitting of the spectral lines, that is indicative of intense magnetic region. Okay.
And is that just with the spins of the particles with or against the field or some such?
Sorry, say that again, Matthew?
Is that just with the spins of the particles that are emitting the light with or against the field or some such?
Okay, I think I got you there. So let me put the question back to the audience, and maybe somebody can rescue me here. Matthew asked, is the magnetic field due to the spin of the particles that are? Can anyone help me on that?
I believe so. Okay.
It's due to the differential rotation inside the sun. The magnetic field lines get all twisted up because they're locked into the gases, but the sun being a gas cloud, the pole rotate different speeds than the equator at different altitudes, so the depths rotate at different rates, so the magnetic field lines get all twisted. And then eventually twist up, kink, and come up through the surface, and that's what starts a sunspot.
Okay.
Because as it penetrates the surface of the sun, the heat from below can't get into the area, the footprint where the magnetic field comes out. And so it radiates the heat away and gets darker, and that's why the sunspot looks dark.
One thing I wanted to point out, and I'm looking at it on the side here, so I'm not 100% sure, but I think this looks like a sunspot here. I remember when I was showing someone at a star party, at a solar observing day, a teenager that a sunspot, and she had seen it for the first time, and she said it looks like acne on the sun, and a very vivid description, which I haven't been able to, you just haven't left my head yet. I want that to go away, but maybe that's probably
Thanks for putting it right.
Yeah. So let's go on here. Good questions, and thanks for the help there. Another prominence here. I'm wondering if this is the one that Simon called. He had a funny name for it on the bottom here. Cathedral or All right, amazing what Mike can do. One of the, just really quickly, what else he has. So Mike has as I said, an observatory in Baja, in his bed and breakfast here. And here's a shot that you can see in the bottom right of the picture. There is I think his 18-inch StarMaster Dob scope, and then the 30-inch is in the middle there, and then of course the solar scope on the sort of the top on the right. I haven't confirmed this with Mike, but you see the floor here, how it's kind of a bit, I don't know what the word is wavy or whatever. So what Mike was saying is that in the daytime, it gets really, really hot. Okay, his black floor. So this might be a cover, I think, that he put on top of it just to keep it cooler, so it doesn't absorb so much of the heat. And I think he's saying when it stands on it, when you stand on it, it's really hot in the daytime. Obviously, he gets more direct light. Okay, next up is Tony Peterson. Thanks, Tony.
This is the, let's get this
You got
wrong.
it.
That's good, okay. Okay, so as Mike mentioned earlier, on the 8th, Mars was at opposition. On the 14th, it was at closest approach to Earth. I wasn't able to get out on a night of decent seeing until the 19th, 20th, and on that night between 9:30 and half past midnight, Mars rotated between those two positions. Those are screen captures from Starry Night. And I do not have an observatory in Baja, unfortunately. I do mine from my backyard in Nepean, so I was using a 6-inch refractor, 2 times power mate, and a planetary camera. And seeing was said to be 3 out of 5, but I think that was pretty optimistic. So that's what I came up with. As you can see, I had a problem with chromatic aberration that night. I don't know what it was. I haven't seen it before in my equipment. I guess something was out of alignment, and I got to track it down before the next opposition, so I think I've got plenty of time to do it. But there's no, really? So it's not my equipment? No. Oh, thank you. Okay. That's why I presented these crappy pictures here, so someone could explain that to me. Well, yeah, but it did quite a bit of damage to those dark areas there. But anyway, I'll just go back. What I was able to image, you can see on the right-hand one, the area of the basaltic shield volcanoes on Mars, which has a yellowish color, was just swinging into view, and I actually did manage to image that. You can see it's just coming out from beyond the red fringe at the bottom of the 1230 when I packed up and went to bed because the clouds came. That's it. Oh, sorry. This is what I think it should do. My equipment, this was a night of good seeing in Israel with a 9-inch reflector. And I think on a night of better seeing, that's more or less what I should be able to get out of my equipment.
Okay, next up is Julia Webster, and she's bringing her dad. She's here to help her dad. Thanks.
Which one changes the slide, Mike? The right-hand one? Okay. So on Sunday, April 6th, Simon sent out an email to the membership from Provence in France. Thank you, Simon. So we got out the solar scope, which is just a 150 mil refractor with the Bader film on it. And we did some observing. And there it is. There we go. So this, what did we see, Julia?
Sunspots.
And what are sunspots? Cold.
Cold dark spots that move around the sun.
Good. So those are the ones Julia picked up. And then Daddy did some too. Got a few more. And then we have them labeled. Are we labeled?
Yep.
Yeah, there we are. Good. Thank you.
We want to know how old Julia is.
She will be 5 at the end of May.
Julia's 5 years old at the end of May. All right. Next up is Paul Clevenger. Thank you, Julia. Thank you, Gordon.
Thanks, Mike. As you know, we haven't had all the greatest of weather in this since the winter decided to leave about a week ago, I guess. So we're crossing our fingers. Did get a few odd nights there. I managed to get a run of sequence on the Sombrero and a few more galaxies that I'll show next month there. So we're crossing our fingers and hoping that the up and coming events are going to be visible to us here, and we'll take advantage of them and image them. But for now, I got the Sombrero early in April. It's an unbarred spiral galaxy, about 28 million light years from here. And even this was shot on a kind of a marginal night there. This is a stack of 8 3-minute exposures through 11-inch telescope using a Canon 60DA. And the thing with the Sombrero is, even in small telescopes, if you do get a clear night, you can actually see that very, very pronounced dust lane that runs through the center of it. It's very, very thick, and as I say, if the seeing is good, you can actually see that. So quite an interesting galaxy to have a look at. So cross our fingers, and we'll talk to you next month.
Thank you, Paul. All right, next up is Pierre Martin, a real treat. Pierre? He's going to be talking about something, potentially a big surprise for us in this month. Thanks, Pierre.
Thank you, Mike. Okay, well, one of the things that, one of the reasons why I've always loved meteor observing and meteor science in general is because you never really know what you're going to see when you're out there. There's always a bit of an element of surprise, whether it's a brilliant fireball crossing the sky, or on a quiet night, or seemingly quiet night, some sort of unexpected meteor activity that might occur. So even though we have several major meteor showers that happen annually every year, approximately on the same dates, there's always a chance that even on the quietest night, that we may be surprised by something that hasn't been anticipated. So as it turns out, we stand a very good chance of seeing something very special in 3 weeks from now, on the morning of May 24th. So that's the Friday night, the 23rd, to the morning of the 24th, to be clear. We have a chance of seeing a major meteor outburst that should at least rival the Perseids or the Geminids, or possibly exceed it by quite a bit. So the stage is set for something that could be really, really interesting. So just how big will this event be, and where's it coming from, and why? So we're going to be looking at that with this presentation. So as we know, the majority of the meteor showers originate from comets. So we have this parent comet that will swing around the sun, and as it moves around, as the sun starts to heat the icy body up, and as comets happen to be relatively brittle in nature and quite fragile bodies, they'll start to shed dust and pebbles and matter along their orbits and start to form a dust trail. And whenever the Earth happens to be in the right spot in the solar system and crosses through one of these dust trails, we get to see a meteor shower like we do every so often during the year. So now about this special meteor shower, let's look at this situation, what's going on with this. It starts back in 2004 with the discovery of an apparent asteroid body, a very small asteroid that had a period of about 5 years, so a very short orbit that brings it out close to Jupiter. So that makes it part of possibly a Jupiter family object. However, shortly after, the object was reclassified as a comet, as observations showed that it had a very dim comma and tail extending. And it was, in fact, an actual comet that was named Lanier, after the automated system that actually searches for Earth-threatening asteroids and quite every so often manages to locate comets as well. So a couple years after, 2006, a book came out from Peter Yenniskens, who's a very well-known meteor expert. And in his detailed book, he came up with the first prediction that in May 2014 we would encounter the dust from this comet, and that it was still very preliminary, even in 2006. So he asked a number of meteor forecasters around the world to verify his assumption and to use their computer models to make more detailed calculations and to try to determine where these dust trails might be in space. So the interesting thing also is that as they started looking at this comet Lanier and what exactly it's doing, they realized that just a couple years ago, in 2012, the comet actually had a fairly close approach to Jupiter. And this caused the orbit of the comet to shift ever so slightly in a direction that actually brings the orbit of the comet very, very close to Earth's orbit. In fact, only 450,000 kilometers from us, which is basically right into our path. So that was the first really interesting aspect of it. And it was quickly followed after by realization that the comet will have a very close encounter at the end of the month on May 29th. It will essentially be buzzing the Earth. In a relative sense, it's going to be the 9th closest comet ever to be passing the Earth. So a very close approach. However, that being said, even though it's going to be passing very close, the comet it looks like it's a very tiny body, and it will not be bright. So at best, we can expect maybe mag 10 or 12. well within range of most amateur telescopes, especially if you have access to a fairly dark sky. So you should be able to see it, but it will not be bright. The very interesting aspect, though, is going to be the Earth's position just a few days before the comet's closest approach. So actually 5 days before the morning of May 24th, the Earth is going to be positioned slightly behind Comet Lanier and slightly on the outside of its orbit. And this is where a lot of the meteor forecasters believe that the thickest dust, or the densest part of the dust trails, is situated right into that area of space. And the Earth will be passing right into that area. In fact, what makes it very encouraging also with this situation is that the comet will be still just at a relatively close point to its perihelion passage, and the Earth will be also very close to the comet. So this has an effect of all the dust trails that were released over the past few centuries from this comet are literally going to be all piled up one on top of another. All these trails, like we're looking at approximately 25 trails from each of the comet's revolutions, essentially all stacked up, which is really exciting, really. To be precise, the trails from 1979 all the way back to 1798, and possibly even earlier, will be where the Earth will be on the morning of the 24th. So this situation initially had the meteor forecasters really excited. And one of them, Jérémy Vaubaillon from France, on his website, he ran his model calculations and stated that we may be in for a major meteor outburst and very possibly a meteor storm. In other words, rates that exceed 1,000 meteors per hour on the zenith hourly rate scale. So that was the initial account. Now so there's one of the initial calculations. What are the dust trails that will essentially be passing very close to the Earth? So this is a 3D model of it. And in fact, the closest trail of the bunch will be passing 0.0002 astronomical units from the Earth. That's really, really close. So to give you a sense of the closeness, it's roughly about 10 times closer than the mean distance between Earth and the Moon. So basically, you can consider it a direct hit with that dust trail, with the center of that dust trail even. So yes, Vaubaillon came up with the initial predictions that the Earth would be having a major meteor shower this month. And here we can see also from his website, it shows the cross-section of the dust trails that are literally all stacked up together, and the Earth's passage going through this area in space. So this is a very exciting picture because you can see the dust grain, it's very, very thick. And however, the dust trails are probably not very wide, even though there's numerous, a high number of them all stacked up. The Earth will probably pass through most of it in about 2 hours' time. So we're looking at probably a fairly short duration meteor shower. But just to give you a sense of how intense this could be, this is an example of a typical Perseid meteor shower using that same sort of cross-section view. Now the scale is a little bit different here, you can see between the dates, but still it gives you an idea. So this is the possibility of this meteor shower and a normal year for the Perseids. It could be something spectacular. Now there's more really good news, and the good news is that North America, and including Ottawa, is favored to see this meteor outburst at night, assuming we get clear skies. Now this is a bit unusual because we've had a few nice meteor outbursts in the past few years. I'm thinking about the Draconids, 2011 and 12. But for whatever reason, like the Draconids always seem to peak right over the Japanese longitude. It seems to be the case, and by the time it's dark this side of the planet, the whole show is already over. So fingers crossed that our luck is changing. So what you're seeing here is essentially the point of view of the meteoroids as they're approaching the Earth. So would be what you're seeing. So the part of the nighttime part here is most of North America is highly favored to see the display, especially the ones that are out on the east or the west coast. Central America and out west will have the radiant as high as it possibly can be. But Ottawa fares nearly as good. And the next bit of good news is that the moon will be just a thin crescent rising right before dawn, so virtually no moonlight to interfere with this shower. So I really wouldn't pay too much attention to whether you're east or west of the moonrise. This is not going to be a big factor. So Ottawa will be ideal, so provided that the shower peaks on time. But there's a really good hope that it will, given that the orbit of the comet and presumably the dust trails seems to be very stable. So we know very well what happened with that encounter with Jupiter 2 years ago and where things are moving around. And it would seem also that with 5 different meteor forecasters all running their independent computer models of the dust trails, all of them agreed consistently that the shower would peak in favor of North America. And the peak being sometime in between 2 o'clock in the morning and 4 in the morning on the 24th. So the next slide is there is a wild card factor though. The potential issue is that the dust, or I should say the comet's activity before 2004, before its discovery, is completely unknown. We know absolutely nothing about the comet's history. No one has ever seen it before. And this means that all these dust trails going back centuries that are predicted to cause a shower, there's no way to tell just how dense or how rich they are in dust. So we don't know exactly how strong the shower might be, but the hope is that the comet has been active enough to produce at least a shower at least as good as the best meteor shower of the year, like the Geminids or Perseids, but very possibly higher than that as well. Now, there's been actually an interesting study just a few, actually late last year, that came out of the University of Western Ontario. Probably the more detailed study I've seen of Comet Lanier and the meteor shower, and the question whether we might expect to see a meteor storm of it or not. And what these guys did is they looked at all the data from the comet and the images and tried to determine exactly what was the activity of the comet, how much dust is it producing, and particularly the size of the dust, which would give a sense of maybe how bright the meteors would be. So they did an interesting study here also, and then I found that really interesting, is that by looking at the shape of the comet, looking very closely at the shape of the tail as well, it's possible to determine the way that the debris of dust is being shed in space. And what happens also is the dust grains of different size will behave differently, will move at different rates compared to larger dust particles. And that's due mainly to the effects of solar radiation acting on those particles. So based on what we're looking at with the comet, it's assumed that the dust grains are actually large. We're looking at probably mainly centimeter-sized pieces of comet forming these trails. And this may sound small, but if you consider that for the most part, the average meteor that we see through the sky is probably the size of a tiny grain of dust. Anything that's centimeter size or larger would probably produce a fireball, or close to it anyway. So this gives hope that the shower may be rich in bright meteors. So The possibility of the bright meteors would also make the shower easy to see within even light-polluted sites. So even from close to Ottawa, you might have a chance to see a very good part of the shower, even despite the dim meteors that might not be seen. So the same study coming out from the University of Western Ontario also gives us this detailed profile of the shower, what the activity is expected to be. And according to their study, they believe that a meteor storm is probably unlikely. And the reason for that is the comet Linear, this comet Linear appears to be very weak as far as dust production. It doesn't seem to be producing a lot. And it's also a very tiny comet, probably less than half a kilometer as far as the size of the nucleus. So their study shows that the shower will peak with a rate of 200 per hour on the zenith hourly rate scale. So assuming that the radiant would be right at the zenith and you would have a very dark sky, the possibility would be for a single observer to see 200 per hour. And the actual rates will probably be lower. And in fact, for Ottawa, having a lower radiant in the sky and any kind of sky conditions interfering would also reduce this rate. But still, this shower would be more than twice as powerful as the best of the annual meteor showers that we have. And according to this graph, the peak would occur close to 2:30 in the morning at solar longitude 62 degrees, so about 2:30 Eastern time. And even after sunset, what we might expect to see is the first few meteors right after the evening twilight. And close to midnight or 1 o'clock in the morning is when things should start to really ramp up as we start to sweep into the main cloud of the dust trails. And then tapering off more gradually into the morning dawn. So this is the prediction now. According to another meteor forecaster, he thinks the shower will be more narrow than this, having a full duration of only 2 hours. So even if you don't see any meteors after sunset, I would strongly suggest that you be patient or you make sure that you get up again and check things out every hour or so, or especially from 2 o'clock in the morning onwards. Because the shower might happen a bit later or not. Any time between 2 and 4 o'clock in the morning seems to be the consensus. And there's a more detailed cross-section view, similar to what I showed you earlier with the one from Jérémy Vaubaillon, but this one is more detailed and actually shows the Earth passing through virtually the very center of the dust trails, so the thickest part of the cloud. Again, right at about 2 o'clock or 3 o'clock in the morning. So again, the interesting thing from this study from the University of Western Ontario, to quote, "We expect that our simulations will overestimate the likely meteoroid production of this comet, though it must be recognized that the earlier perihelion passages which produce particles intersecting the Earth in 2014 may have benefited from higher gas production rates than the comet currently displays. In other words, if the comet was very active in its past, we could get a much better show than anticipated. And the opposite could be true too, that if the comet sputtered out in its history, we may be passing through the trails, but it could be an empty area of space. So this is the part that remains a bit of a mystery. And so their conclusion is that the peak will occur at about 2:30 in the morning with a full width and at half maximum of 0.4 days. So they actually show a broad lasting shower, lasting almost half of a day. And of course, we may be in, because of that study, the possibility that this comet is turning dormant, that it has essentially burnt out most of its dust through a lot of its cycles, that what's left over now is probably the larger chunks. And if that is the case, then even if we don't see a meteor storm, we might see a very brilliant shower. So now the situation for what we might expect to see here in Ottawa. So to view the shower, here's what the sky will look like at about 3 o'clock in the morning, all depending on what the meteor shower will do. But the radiant is going to be located right below Polaris. So there's a little dipper, Ursa Minor. So it's in essentially an empty or relatively blank spot of the sky, close to Polaris, and the constellation Camelopardalis. So this shower has not been given an official designation or name yet. We don't know if they're called the Camelopardalids, or maybe it's going to be named after the comet, which I think is going to be easier to say if we call it the Lanierids. But we don't have that information yet. I guess they're going to wait until we know if the shower actually occurs before it becomes official. So facing north would be your best bet to see the shower, either traveling north of the city or away from the light pollution if you can. I would actually suggest, if you can, to go out to the FLO out west in Ottawa. It's less than an hour's drive from downtown, not too far. And the difference in what it might do compared to anywhere in the city would be very, very high. It would be well worth it getting out of the city, even if it's 20 minutes out. The other good news we have is the shower happening on the morning of May 24th is actually a Saturday morning. So this is also a bonus. Now the thing to keep in mind is with the radiant being located where it is, 35 degrees high at best. It will not get any higher than that. It will be up all night, so the shower, if it happens a bit earlier or later, we have the advantage of the radiant being in the part of the circumpolar sky. However, what this means is if the shower has a ZHR of 200 per hour, we can probably expect to see an actual rate of 50 to 60% here in Ottawa because of the lower radiant. So a lot of meteors will actually be shooting down below the horizon. Those that we see far from the radiant will actually produce nice long streaks. So we do get a bit of a consolation prize for even if we don't see the maximum number. But what's also really interesting with this meteor shower is that the entry velocity of these meteoroids will be only 18 kilometers per second. So as far as meteors go, this is very slow. Compared to the Geminids, which are twice as fast, and compared to the Perseids, which are 3 times faster. So these meteors will be very distinctive. If they happen, there'll be no mistake. They're going to seem to crawl in the sky just a little faster than what a very fast-moving satellite would appear. And if they are very bright, it would also mean that this shower would be photogenic. It would be a really nice one to try to catch. So if the shower is a little bit late and happens an hour or two later at 4 o'clock in the morning, we're going to be really into the beginning of morning twilight at that point. So the shower hopefully will be bright enough that if it does happen close to morning, it should still stand out beautifully. Now the radiant for this shower, here's a more detailed view. It's actually not truly a point. And because of the possibility that we're going to be striking so many dust trails that span a few centuries, the meteoroids are actually assuming each a rather individual orbit that closely follows the comet's orbit, but not exactly at that same position. So this has a result of creating a radiant that's slightly diffused. That's actually an area of the sky where the meteors will seem to stem from. And this is also an assumption. The radiant might actually be even larger than this if it's very diffuse or possibly maybe shifted from this position. So the very interesting aspect also, which is a bit unusual, is the chance to observe Comet Lanier and the meteor shower at the same time. So a chance to see the parent comet actually causing the meteor shower. So we're going to be able to see it for a little while, especially the last few days of the month. It's actually going to be passing right through Leo. So the comet should be within range. of most telescopes, shining at about magnitude 12. But it's not often that we get to see the same comet that produces a potential meteor shower, and we have that chance. Right around the end of the month, we're going to lose it. At that point, I believe the comet will be right at the horizon, or we're going to lose it down in the glare of the sun. So a few tips about meteor observing. So really the thing to do is to try to get as comfortable as possible and to be patient. Because the meteors, even if it's a big meteor shower, it can be a test of patience. Meteors don't necessarily arrive on cue. You can have several minutes without nothing happening, and then also in a burst of several within a minute. We never know. I find that's a part of the excitement. So make sure you bring something that you can lie back, be comfortable, take into account nights, even in late May, can still be on the cool side. Bring a snack, bring company also to try to keep you awake. And yeah, basically be ready to enjoy. And also it can be buggy. So if it happens to be a hot night, make sure you're prepared for that possibility, especially if you're outside the city and out in the woods. Personally, what I really like is the thermocell. It's a little appliance that just really takes care, creates essentially a bubble around me that's mosquito-free. It really makes a difference, and much more ideal than spraying off on my skin and then risking that I'm going to damage my optics or my camera gear, because that stuff is so strong. And with this shower coming up, if it happens as it does and as we hope for, would be a very interesting target to photograph. If you have a digital SLR, a tripod, and a remote controller for your camera, you're pretty much all set. You have the basics. And I won't get into all the details, but what I strongly suggest is that you do a test run ahead of time. Make sure your equipment runs, that your batteries are fresh, everything is working as it should. And in a general sense, what you want to do for meteor photography is try to use the fastest ISO possible, the widest aperture possible, and a reasonably long exposure without anything that's going to wash out your picture because of sky glow or light pollution. So again, this is trial and error. So probably best you set up at your site ahead of time, run a test, make sure that your photos are acceptable. It's better to actually run shorter exposures and have numerous exposures that will prevent your images from becoming washed out or too grayed out. So here's a summary. We will pass through multiple dust trails from Comet Lanier on the morning of the 24th. And the expectation is a shower that could be anywhere between 100 per hour to an upper limit of 400. Meteor storm appears to be unlikely, but to be honest, and the meteor experts pretty much say the same thing, it cannot be ruled out. We just don't know enough about the comet's history that anything can happen, and we should be ready for the unexpected. So very high meteor brightness. And also, lastly, all observations and data for this event are extremely valuable, whether it's images or formal observing reports. And what I would recommend is have a look at the May issue of the Sky and Telescope magazine. There's actually a nice article talking about this meteor shower, and also there's a nice sidebar about how to submit your observations to the International Meteor Organization. And by keeping it simple, without going into a very detailed report or calculations, you can actually contribute a little piece to science with minimal equipment or knowledge, just by being out and making sure you're vigilant with the time and you're patient, and you can actually contribute and make a fair difference. So I guess all we have to do is fingers crossed for good weather. Thank you.
Thank you, Pierre. We don't have time, unfortunately, for questions, but Pierre, if you can maybe if you could stay around after the maybe there might be somebody that'll come forward and ask questions.
Will do.
Thanks a lot, and hopefully we can have a trip a report in the coming months as well. Last presentation is John Thompson, as I mentioned earlier. I talked to him at the end of the last meeting. He really got me quite excited about his recent trip to the Atacama Desert. Clearly one of the premier dark sky observing spots on the planet. I'll let John take it from here. Thanks. John.
Thanks, Mike. As you mentioned, last meeting, I just arrived back in Ottawa about 2 or 3 hours just ahead of the meeting, so I was still kind of weary. Anyways, it was a great trip. I heard about this through some connections with the North York Astronomical Association, that they had planned it for themselves, but they didn't get enough people, so they advertised it outside that group. A few Americans came, including Fred Espenak, Mr. Eclipse, who makes all those nice tables and drawings in the Observer's Handbook. So, first of all, for people, just to say where we are, it's in the northern part of, not quite the northern part of Chile, up towards Bolivia. It's in the desert area because of the coastal mountains. The moist air coming off the Pacific drops the moisture on the windward side, and then it gets dry on the other side, which makes the Atacama one of the driest areas in the world. And a little closer, where we were was a place called, just outside the town of San Pedro de Atacama. That actually, this place is called the Atacama Lodge, but it's also called SPACE, which was an acronym, which is San Pedro de Atacama Celestial Explorations. That's the name of the business, and it came out SPACE. So here's his webpage. That's, see, he calls it SPACE, Atacama Lodge. And the services, there's a number of businesses. They have the accommodations, like, it's not quite a bed and breakfast, it's lodging, but they're kitchenettes and you have to do your own cooking. They have star tours, and they have telescope hosting, telescope rental. If you want, you can go down there, set up your own observatory, and for $5,000 a year, he'll provide the power, the internet, and all the maintenance. And there's quite a few people from around the world that are actually doing that. And we rented, our group of 11 rented a 17-inch Dob for 6 nights, and it's about $95 a night, so it worked out like $10 a night for us, which is a pretty good deal. This is first, there's actually only 5 lodges that, these are the first 2 lodges, 1 and 2, which are mainly made for couples. I guess they like they're set up for just double beds, and then this is lodges 3, 4, and 5. I was in lodge 4, and there are 2 bedrooms, 1 double bed, and then 1 room that has 3 single beds in it. Lodge 5 was the biggest one, and that's where we would sometimes meet when we had a day trip coming up. The next day we would meet in the evening in Lodge 5 just to get the directions. Here's our group. Half of them are from Toronto. I was the only one from Ottawa. My lodge mate is that Chinese man. He's a medical doctor. He's 70 years old, if you can believe that. His name is Willie Yi. The man in the front is Greg. He's out. This is his 4th time down here. Dave Cotterill is beside him in the red, and he was the group leader. That he was sort of deputized into that at the last minute because Malcolm Park, who had organized this trip, had to drop out at the last minute for medical reasons, unfortunately. And on the back wall there, the man in the white hair looking to the left, that's Fred Espenak, Mr. Eclipse, who does all of those, like I said, those eclipse tables in the Observer's Handbook. And then to his right, that couple there, those are the owners, Alain Maury, he's French, and his wife, Alejandra, is Chilean. Alain used to be a telescope engineer at several major observatories around the world, and then he decided to start his own business when he saw how dark the skies were here. And then he met his wife, whose background is tourism, in Chile, and they got together, so they've got this really neat business, and they're just, living their dream here. This, a couple of times we got together for a potluck at Lodge 5, that's what we're doing here. So we've got, really good life here, good food, good friends, good Chilean wine, and then the spectacular view off behind the lodges. So this is getting around sunset, and the mountains are illuminated by the sun from the west. Here's our observing field. There's our Dobsonian rental. There's a couple of dome segments off to the side there. Most people didn't bring their own telescopes because of just the cost of, hauling them down there, but we can rent them, so it made it easier. But to the very far right is Dave Cotterell's telescope setup, and that structure to the left is a swimming pool. It was too cold by that time to actually use it, though. It was an outdoor pool. Here's the telescope hosting area, and I don't know if people recognize those domes. That's a Canadian-made thing called Astrohaven domes. It's a company in BC, and there was actually a couple of Sky Sheds also, which is another Canadian company from Ontario. So there's actually strong Canadian connections here. And this, all of the power is self-contained. The power from San Pedro is unreliable, so you can see solar panels there. And off to the right, there's a building that's full of maybe 100 or so storage batteries and a big inverter that provides all the power. And that tower is his internet connection. Internet was a bit slow. All the lodges had Wi-Fi, but in the morning especially, it was a bit slow because all the telescopes are using the bandwidth to upload their data from the night before. This is the Sky Tours part of the business, that twice each night there'd be a bus full of tourists from San Pedro, which is about 10 kilometers away, would come in. For 2 hours, they'd show them the sky with green lasers. Well, maybe for an hour, they'd show them the southern constellations. Then for the second hour, they'd look through these telescopes, which are all arranged at various parts of the sky and, objects of interest. And then at the very end, Alejandra, Alan's wife, would come out with coffee and tea and hot chocolate and those sort of things just to end it off. And so there was actually 2 rounds of that each night. And the very last night, Alan let us have use of those telescopes on the house. There's actually 2 24-inch telescopes, 3 between 18 and 20, and then the rest are, 10, 12, 16 size. And then we're just waiting for sunset. There's about this time you'd start to hear these domes starting to open up because they're all remotely controlled. By some, there's one owned by a bunch of amateurs from Russia. There's another owned by a Polish university. They have different, and then it's twilight. We're just getting nearly there. And then here's the sky that we were waiting for. Really magnificent. There's no moisture there. The humidity is about 5%, but because it's dry and windy, it does kick up some dust, and that's what that sort of reddish not glow, in the background and towards the horizon. But you can see how the stars go down almost right to the horizon. The part to the Milky Way to the left, that big dark thing is the southern coal sack. Right above it is the Southern Cross, or Crux, and then above that is what is probably the most interesting part of the entire Milky Way and the entire sky, which is between Crux, Carina, and Vela. We're looking endwise into a little spur off the Sagittarius arm called the Sagittarius Carina arm, and there's an intense star formation going on in that part of the sky, so there's just dozens of interesting deep sky objects. Diffuse nebula, open clusters, dark nebula, and then off to the right, of course, are the Magellanic Clouds, the large one at the top and the small one further down. Here's the observing field in our 17-inch, and one more view of it. Towards the end, I made a panorama that's 5 images put together, and you can see the Sagittarius is right up almost at the zenith at that point. Well, maybe it's 70 degrees altitude. And pardon, do you have a laser?
Yeah. Top button on it.
Oh, okay. Now, what do you want pointed out? Sagittarius is right in here. There's the Scutum star cloud. You see on the other side, there's another star cloud that's sort of symmetrical, nice symmetry. And then also, this is the Cygnus arm, Cygnus Orion arm here, and then here's the Sagittarius Carina arm, so we can sort of see the symmetry of these spiral arms of the galaxy.
Where's the Southern Cross?
Right in here. It's kind of hard to see. It's right by the coal sack here. And the Magellanic Clouds, I believe, are those things that they'd be getting down to the horizon at that point. There's a couple of little light domes you see. One is the city of Kalama that we passed through coming here. And the other one, I was told, is a lithium mine that In northern Chile, that's one of the biggest industries is copper and lithium mining. This is, you see Orion here? Up here, sort of upside down, there's Jupiter, Castor and Pollux, Aldebaran and the Hyades, and then here's the sword of Orion and the rental or the hosting telescopes. This is a little shed with an HEQ6 mount that I rented with another guy for 2 nights to do some astrophotography. We each had a DSLR and we're sharing the cost of that. And there's Orion again above me. Up there's sort of at a funny angle. And I've got a number of astrophotos, but I only put in a couple of them here. This is my favorite one. That was taken with a 50mm lens being tracked. And that was actually just a 30-second exposure at ISO 800. Again, you see the coal sack. There's the Southern Cross here, 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 and that star. There's something apparently called the False Cross that somebody pointed out. It's a similar shape but larger further down the Milky Way that, if you didn't know better, it could fool you. There's H2 regions, another hydrogen gas. There's the Eta Carina Nebula, which sort of resembles the Trifid, except it's many times bigger than the Trifid. And another bright open cluster there. And here's, I just did a close-up of that. I cropped it. There's the Eta Carina Nebula. In the telescope, my impression of the Eta Carina, it covers over something like 2 degrees. It resembled the Lagoon Nebula, except what I put in my logbook, I said Lagoon Nebula times 20. That's about what it was like, just in terms of intensity and size and brightness. And then NGC 3252, I believe, is another brilliant cluster full of hot O and A stars in here, large too.
That Eta Carina Nebula is visible to the unaided eye.
Oh yes, certainly.
When there's still twilight glow in the skies.
Oh, there was a lot of these objects were invisible to the naked eye. Omega Centauri, 4 to 7 Tucana, a number of star clusters. Like either one of these objects would be outshines anything in the northern hemisphere, and here they are just a few degrees apart. Here's, that was taken with a 200mm telephoto. That's a stack of 12 images of the Large Magellanic Cloud. Again, here's the Tarantula Nebula. That's a naked eye object. And sweeping around in here was just fantastic. All sorts of open clusters and H2 regions. There's actually 318 NGC objects in the Large Magellanic Cloud, and one survey says 60 globulars, 400 planetaries, and 700 open clusters in there. And I don't know how many H2 and diffuse nebulae. Towards morning, we get the zodiacal light. There's Venus, Mercury, and the summer Milky Way that, on my original image, you could see most of Cygnus, but I sort of clipped it because it was a bit of vignetting at the corners. So just about the end here, and this is dawn coming up, little crescent moon. A couple of nights before that, that moon was right beside Venus, and several nights later, when it got to the other side of the sun, we saw that crescent moon when it was only 9 hours old. I'd never seen a moon that young before, and we were able to follow it right down to the horizon. I didn't bring a telescope, but I did bring 20 by 80 binoculars, which I was able to make quite a few observations, and then, of course, sharing the 17-inch Dob. And very quickly, we had a day trip to the Paranal facility of the European Southern Observatory. It's 4 8.2-meter telescopes and 4 1.8-meter auxiliary telescopes, which can be arranged either just to add their light up to make equivalent to a single 16-meter telescope in terms of light grasp, or they can be arranged as an optical interferometer to give the equivalent of a 200, like the resolution of a 200-meter telescope. They claim it's the most advanced astronomical facility in the world. There's the 4 domes with the 8.2-meter telescopes. Optically, they have they have active optics and adaptive optics. The mirrors are 8.2 meters across, but only 17 centimeters thick. They're very, very thin. So they have computer-controlled actuators underneath them to maintain the shape of them. That's the active optics. The adaptive optics is they use a laser beam to create an artificial star, which is used as a model to model the scintillation of the atmosphere and then correct it with the active optics. So they were able to get very, very good resolution. Also, because of the thin air, there's less atmosphere. It's 2,600 meter altitude. And those are the 3 of the 4 auxiliary telescopes that they ride along on rails so they can change the resolution and spacing. This sort of thing's been done for decades with radio telescopes, but it's only in the last 3 or 4 years, I think, or last decade, that it's been done in optical telescopes. They have to maintain the light path to less than 1 micron across 200 meters of distance in order to maintain the fringes. That's the the VST, the VLT survey telescope, which is the biggest survey telescope in the world. Somebody asked, one of the guide asked if we could guess what VST stood for. Somebody said very small telescope, but actually I'm not sure what size it is, but I think it's nearly the size of the 8.2 ones. And in another peak over there, there's a 30-meter telescope, which is on the drawing board that they're going to be building within the next 15 or 20 years. I think that's okay. No, there we were able to get inside one of the buildings, one of the observatory buildings. When they're in operation, there's nobody inside at all. There's a sort of a panorama. I didn't have a wide angle lens, so I pieced together a few of them. I think that may be that's the last one.
Thank you, John. Again, I don't think we have time for, we definitely don't have time for questions right now, but John will be around after the break. And John, thank you for going through this as quickly as you did to respect the time. I mentioned earlier that about something that interests me, and I sent an email to council, our Ottawa Centre Council, about possibly arranging a group trip to the Atacama Desert. So I'm exploring the idea. I'm trying to get some idea of cost. John, I'll be in touch with you because it sounds like you know a lot about this. But I am going to look into it, try and get some idea of what's to see, what things to see other than what John mentioned and costs, and I'll be in touch. Okay. Let me wrap up really quickly with a bunch of announcements. Is Rob here? Rob, why don't you come up and talk really about this for 1 second, and after Rob's announcement here, I'll do something really quick, and then we'll close the meeting. I'll do the door prizes. Thanks.
I didn't know about the meteor shower, but it's the same weekend as a meteor shower. May 23rd, 24th. Every year, generally, I have 2 open houses in my observatory, one in spring, one in autumn. The reason for spring and autumn is because the nights are longer than in summer, and it's a lot more, you don't get frostbite because of winter. It's got a 24-inch telescope, Newtonian Cassegrain, plenty of space to set up telescopes. It's open on the Friday when I get up there. On the Saturday evening, we usually go into Perth for some dinner. If you're interested in joining us for dinner, let me know well in advance so I can put in a reservation so you don't end up doing dishes. But if you're interested in getting the map to the place, my email's at the top. Relatively simple, rdick@robertdick.ca, and I'll send you a map and I'll note your interest and put you on the list. And encourage you to come, bring your telescopes. If you have a telescope you don't know how to set up, bring it along, we'll help you. If it's got a 20-page manual, don't bother. Okay, thank you.
Thanks Rob for hosting this every year. It's very kind of you to do that. A couple of quick announcements here. International Astronomy Day. This is an event that's celebrated globally, really, but there's a couple of prominent activities in town I wanted to mention. One is the museum hosts an event, and actually that's Saturday, May 10th. That's next weekend, I guess. And our Ottawa Centre is participating in this, as we have in previous years. There'll be daytime activities, solar observing, indoor displays, and likewise in the evening, of course, all weather permitting, the outdoor solar observing as well. We already have a number of RAC volunteers. If you're interested in volunteering, contact Chris. You do need to be a museum certified volunteer, which means you have to have had a police check. Okay. But again, that's all free for you. But if you're interested in volunteering for the daytime or evening, contact Chris really quickly here. I also wanted to mention, I don't have a slide for it too, our sister astronomy group, the OAOG, the Ottawa Astronomy and Ottawa Valley Astronomy and Observers Group. They also host a very large event. Also on Saturday, May the 10th at the Silver Cities chapter on Blair Road and Ogilvie.
Blair and the Queensway.
Blair and the Queensway?
Ogilvie and Blair.
Ogilvie and Blair. And their event starts at, I'm told, at 10 in the morning. It's all day, and it goes well into the night. They have presentations. I understand from the agenda that Pierre Martin will be giving a presentation on meteor shower observing and so forth. They have quite a large setup with telescopes, another really great venue. So that's something available to us as well, and it's also free. Next slide, please. Okay, I mentioned earlier about the key renewal of Ron St. Martin. Next slide. I also mentioned the previous month, there's the RAC national positions. If you're interested in, and if you're an RAC member and you would like to sort of maybe take on a role that's a national role, there still are a number of positions that are available. If you're interested in this, go on to the RAC.ca website, and there's information on eligibility, the application process, and the campaign process, and so forth. So. Next slide. I mentioned also earlier that if you want to watch this broadcast, go to this website. Easier still, just Google RAC Ottawa Centre Ustream. Okay, any combination of those words, and you'll find this website. It'll be posted in about 15 minutes. So if you want to watch this again. We have every month, Estelle has who's our librarian, has a pick of the month, and this month it's the Quest for Comets. By David Levy. Thank you, Estelle. The library will be open right after this meeting. Also, you're welcome to join us. A number of us go to Kelsey's, just at the corner of the street for some post-meeting drinks and cheer. Open to everyone. We had altogether tonight 108 in the audience, and 108 people that attended in the audience, and we don't have a count for the number of people online. But thank you for all the organizers and Chris and Eric particularly. You guys make it real easy. Thanks a lot for that, and all the presenters as well. Next month, it's June 6th. It's also our swap table where you can swap items and exchange items and sell items. Next meeting is going to be also an interesting meeting as well. Some of you who have been members for a couple of years now will remember Dan Falk. Dan gave a talk on, and I can't remember the name of his book. It just escapes me right now. Time.
Something about time.
Something about time. Anyhow, he's back. He's a science journalist, and he has released a book on the science of Shakespeare. This is not a presentation on Shakespeare. This is a presentation on astronomy aspects that are brought up in Shakespeare. Go on the website. There's more details about it. I've had a number of exchanges with Dan Falk. It sounds like it's going to be really something. We're also going to promote this on the radio, and hoping to build a fair size audience as well. Tim Cole is going to be talking about the evolution of instruments that lead up to the astrolabe and beyond. Next. Okay, I think that is it. We're going to formally close the meeting now. Thanks very much, those of you who joined us online. Thank you for your time. And now we're going to host the door prizes, or have the door prizes.
Thank you.